guys, today we're going to look at G3. G3 is where we're going to take area and perimeter and we're going to actually apply it to coordinate planes. But before we can really do that, we need to talk about reflections and distances. So in this lesson, we need to understand what the x-axis is and what the y-axis is so we can understand how to get from one point to the other. So your x-axis is this green line here. It deals with things going right and left. Now, if you remember, when we talked about number lines before, we have this right here in the middle that is our zero. The zero is our neutral. It divides up our number line from positives and negatives. So if we take this y-axis and we put it right here, the y-axis is acting as a zero for the x-axis. So it is a dividing point. And your x-axis is doing the same thing for the y. So basically, if I talk about going right, I'm going to be going right on the x-axis, and your y is going to deal as your zero. And it's also going to meet, and that's where we call the origin. That's your 0, 0. So let's go ahead and look at some problems that will deal with this. So now, let me get back here. We're going to take our numbers and we're going to reflect them, our coordinates. I'm sorry, not numbers, but we're going to take our coordinates and we're going to reflect them. So if right here we have z. On z, I want to reflect it across the y-axis. So what that means is I actually have to get to the y-axis and go across it the same amount of times it took me to get to the y. So our absolute value here of this -2 would be 2. It's going to take us 2 places or 2 steps to get to the y. And then I'm going to have to go 2 more to get to our next one. So this is me crossing the y-axis. So my new point is now going to be +2, 6. Because I crossed the y-axis, my x changed. Okay, so notice this. Your x was -2. You cross the y, now your x is +2 because remember your y-axis is cutting your x at 0, okay? So you're pretty much, that would be like saying you're at -2 and you need to get to +2. How far apart are you? You're 4 spaces because you got to go 2 spaces to 0 and then 2 more to get to +2. So yes, these are coordinate planes, but you have 2 number lines that are put together here. All right, so now let's look at x. If we have x at 3, 3, and we want to cross the x-axis, your y value is going to change because in order to cross the x, we have to go down. And when you go down, that's you changing your y value. So we're going to go down 3 more. So that's going to put us at -3, 3. Okay? So notice, wait, I did that backwards. When you cross the x, your y changes. I did that wrong. So we got 3. -3. Because we went down, that changed our y. Well, up here, we went right, so that changed our x. So just remember, when you go right and left, that changes your x. When you go ups and downs, that changes your y. So make sure you're paying attention to that. Now, if I want to know how far apart these would be, obviously we would do the absolute value of 3, absolute value of -3, so that would be 6 places away. All right, so let's look at another one. All right, so on these, we're going to actually find the distance. We're going to find the distance between A and B, and then C and D. All right, let me move that. All right, so over here, we're at -2, 3, and over here, we're at 4, 3. So different quadrants. When they're in different quadrants, you have to add the 2 absolute values. So, here's the reason. We have a 2 to get to the y-axis here. Then we've got to go 4 to get over here to B. So that's going to be 6 places. Or you can say the absolute value of -2 plus the absolute value of 4, which is going to be 6, because you're talking about 2 places and 4 places. When you're talking about absolute value, you're not necessarily talking about direction. You're talking about distance. Absolute value is all about distance, not direction. So that's how we got 6 places, because you can say A is 6 places from B, B is 6 places from A. You're not necessarily saying B would go -6 to get to A. You just want to know how far apart they are. All right, so then we can also look at this one, C and D. Now, if you notice C and D are in the same quadrant. They're in quadrant 3. I want to subtract these 2 because they're in the same quadrant. Now, if you remember over here in quadrant 1 and quadrant 2, we added these because they were in different quadrants. Here, they're in the same quadrant, so we're going to subtract them, which is a little different than probably what we're kind of used to at this point. But it should make sense to subtract because you're saying 1 well, let me get this right. We're going 1, 2, 3, 4, 5 places apart. So notice that your x-axis, your x value did not change. Your y value did because it dealt with the up and the down, okay? So we're going to take -2 and -7. So the absolute value of -7 minus the absolute value of -2. Okay, notice I'm subtracting here. So the absolute value of -7 is 7. The absolute value of -2 is 2. So basically you're just saying 7 minus 2. They are 5 spaces away. So remember, your x, if your x value changes, it's because you are going across your y. Okay, if it changes from a positive to negative, you're going across the y. Pay attention to the fact that the y is your x is 0 and your x is your y 0. Also, the next thing we need to look at is if they're in the same quadrant, you subtract them just like we did here. If they're in different quadrants, you're going to add their absolute values. Okay, so make sure same quadrant, you're going to subtract them. Different quadrants, you're going to add to find their distances.